Okay, guys. Today we're going to be wrapping up linear equations. Please know that when I say we're wrapping up linear equations, we're just wrapping up Chapter 5. We're no way near done with graphing linear equations. We still have systems of equations to go over, and one of the methods is by graphing to solve. And then we still got to learn how to solve linear inequalities. Linear inequalities have the same exact rules, just a couple little things are different. My point, if you don't know how to find a slope yet, as of right now today, please, you better learn it. If you don't know what the difference between the point slope form and the slope intercept form is, please, you better know it. If you don't know how to write an equation, if I give you a point and a slope, you better learn how to do that. If you don't know how to write an equation, if I give you 2 points, you better learn how to do that. If you don't know how to find a parallel or a perpendicular line, if you don't know how to find a parallel or perpendicular line to a given line going through a given point, you better learn how to do that. Not just for now, but for the rest of your math career. Trust me, guys, it's really important. So today, we're going to talk about scatter plots and trend lines. Now, scatter plots and trend lines, you can get really complicated with this stuff, and we're not going to go that complicated. There is something called a correlation coefficient. It is represented by a letter R, lowercase r. And that correlation coefficient can be found using a scientific calculator. We don't use calculators in this class, so we are not going to worry about the correlation coefficient. Okay? We're simply going to learn about the math and how to look at a scatter plot and by hand create what's called a trend line or a line of best fit. And we're going to write an equation for that line, and then we're going to make predictions based on that line. Now, look at what we have here, guys. We have the first one here is a positive relationship. Can you guys agree that this black line is somewhat in the middle of all of these different values? Okay. When you have a relationship that's increasing from left to right, not only is that a positive slope, but it is a positive relationship or a positive correlation. What's happening here in a positive correlation, as one variable increases, the other variable increases, okay? So in this particular example, as foreclosures are increasing, that is foreclosures when you lose a house, unfortunately, because you can't pay anymore. As the foreclosures increase, so do the household units. They increase. Because if I have 5 people get foreclosed on, guess what? There's 5 houses now that are empty. There's 5 houses on the market. So that's a positive relationship or a positive correlation. Negative relationship has a negative slope going down from left to right. As one variable increases, the other variable will decrease, or vice versa. As one variable decreases, the other variable will increase. Look at the correlation that they have here. Unemployment rate at the percent of college educated. The higher education you have, guys, look at the unemployment rate. It's real low. The lower your college, a lot more unemployment. That's why it's so important to get an education. Because the more educated you are, the more chance that you will not be unemployed. If you don't have but a high school education, you're probably going to be floating from job to job for a long time. Because why would I hire you when I could get someone that has a college education is my point. Remember, this isn't personal. It's business, guys. Businesses want the best of the best. Schools want the best of the best. Okay? If you don't have an education, you're going to be stuck with a minimum wage job, which is fine. And there's nothing wrong with that. But it's a fact that the more college you have, the less unemployment you have. So think about that. So that's a negative relationship. And now, no relationship. No relationship is no relationship, okay, guys? There is no relationship between the two variables. For example, in this instance, percent of college educated and the pet owners. What? What does that have to do with anything? I know doctors that don't have any dogs. And I know guys that, didn't go too far in education that have 5 dogs. Doesn't really matter. Just because you have a master's degree doesn't mean you have to have 4 dogs or 4 cats. That's just like saying your grades and hair length. One has nothing to do with the other. There's no correlation there. But now if I tell you your grades and the amount of time that you play video games, that's a negative relationship. The more video games you play, the less grades you will get, the lower the grades will be. So that is what scatter plots are. Now, we're going to be doing two things with scatter plots. First of all, we're going to create a trend line. That was that black line in the examples of above, the line of best fit on the scatter plot. Okay, it's drawn near the points that shows a correlation. You're going to try to draw a line, this trend line, this line of best fit, exactly like what it says. It best fits the data that they've given you. It best fits the data that they're giving you. It best fits the data that they are giving you. Okay? And then from there, you have 2 things. Interpolation and extrapolation. Interpolation is estimating a value between 2 known values. Okay, for example, let's look over here. Let's say that this is year 1 and this is year 2. And I want to take this point right here. Actually, you know what? This is not a good example because I don't have any numbers. Let me show you something for interpolation. Hold on. Let's say that I tell you, you have the following graph. Let's just say the donuts you eat, okay? Donuts you eat, and your weight, okay? The more donuts you eat, of course, the more you will weigh. Well, let's just say that this was 6, and let's just say that this is pounds, and this is at 100 pounds. Let's just, for giggles. If I want to estimate the number, the weight that you will have when you're eating 5 donuts a day, there's no real point for here. It's an estimate. So you would estimate, more or less, you do an estimate here between these 2 values. Okay? That's what interpolation is. Extrapolation is predicting a value outside of the range of known values. Extrapolation is, okay, what are you going to weigh when you're eating 32 donuts a day? You would have to keep graphing, and since you don't have enough information to keep graphing, that's where your line of best fit or your trend line comes into play. So again, interpolation, you're going to look at the graph that they give you, and you can estimate a value. Extrapolation is actually plugging in that value into an equation that you created and finding an estimate. Now, let's get to this, because it is really simple, guys. Like, I mean, really, really, really simple. Okay, let me see if I can expand this a little bit. I cannot move it, though. Okay. All right. Oh, yes, I can move it. How did I move that? Okay, let's see. Oh, there we go. Make it even larger now. Okay, perfect. Okay. Let's read the problem, and then let's get to it. It says here, gentlemen, that make a scatter plot of the data to the right. Well, actually, below. What is the approximate weight of a 7-month-old panda? They have the months, the age, and the weights of different pandas at different ages. I want to be able to make a prediction. So if I'm going to make a prediction, I'm going to be extrapolating. So that means that I have to create an equation with all of these values. So it's very simple. Step 1, graph the data that they've given you. So let's go ahead. I'm going to use age is X because it's always independent, and the weight is Y because your weight depends on your age, right? The older you get, the heavier you weigh. I weigh a lot more now than I did when I was 3 years old. Okay, as you grow, especially with pandas, as you grow, you get heavier. So on my X, I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14. And on my Y's, I'm going to go by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. The good news here, okay, let's just make one little extra line there. The good news here is you can estimate this graph as far as when you're graphing the actual points. Go ahead and graph them with me while I'm graphing them here on the board. First point, 1, 2.5. So 1 is between 0 and 2, right? 1 and 2.5, it's about half and half. Right? Does that make sense? 2, 7.6. 2, 7.6 is about there. A little bit over halfway. 3, 12.5. 3, 12.5, it's about right there. 4, 17.1. 4, 17.1, it's not exactly at half, a little bit under half. 6, 24.3. A little bit under 25. 8, 37.9. 37.9, it's a little bit above the half mark here. 10, 49.2, just a tad bit under 50. And 12, 54.9, really just below 55. Now, if you see this and you try to connect this, guys, look at what happens. Do not connect this on your paper. Look at what happens, though. Is that a linear equation? No, right? Because it's got too many curves, right? Okay. So your first step was to graph. Does everyone understand how to graph so far? Right? This part's Mickey Mouse, right, guys? Okay, here comes the interesting part. I've got to make a trend line. And there's a lot of different choices that I have here, guys. I don't want you to think, oh my God, what if I don't pick the points that Mr. Morrow picked? I don't care. As long as you give me a reasonable trend line, and as long as you show me the work of what you did, I'm not going to stress it. Let me show you some things that are not acceptable, though. If you say, oh, my trend line's here. No, unacceptable. Has to go the whole length of the graph. You say, oh, this is my trend line. Not even close, because it's not going to the points that was given. If you say, oh, okay, this is my trend line. Not even close, because it's not going through all of the points of the trend line. So what you want to do is have something that goes as much to the middle as possible. So I like to choose 2 anchor points. So step 1, graph it. Step 2, choose 2 anchor points. The anchor points I'm going to choose is this guy and this guy. Why? Because when I connect those, does that pretty much go to the center of my data, guys? Is it perfect, guys? No! No! Could you have chosen this one and gone up like this? Not really. It wouldn't have been good because, look, all the points are above it. Yes, sir. You have to go through the center of the graph. That's going pretty much to the center of the graph. Look, right on the center. This is below it. Just a little above. That's pretty centered, man. It doesn't matter. It's not touching this last one because we want an estimate. Thank you. Great question, sir. I'm sorry? The line needs to span a good majority of the points. Like I said, if you do this to me, that's my line, I'm going to mark it completely wrong. Okay? You have to get an anchor point that's somewhere near the bottom, somewhere near the top. Connect those dots. So far, if you graph it, you get points. If you give me my trend line and you show me that you put your anchor points and you connect the dots, you get points. Now, the easy part. And again, I'm going to let you estimate here. This anchor point was this guy, right? And the last anchor point was this guy, right? Guys, if we're going to do a y2 minus y1, we're going to get a nasty decimal, aren't we? You have my permission when you have scatter plots to round. So my x1 and my y1 is going to be 2, 8. My x2 and my y2 is going to be 1255. Again, you have my word of honor on my tests, on your homework. Your self-assessment may not do it, but on my homework, on your tests, I promise you, you are allowed to round the points to make it easy. Yes, sir. 2, 8, because 7.6, buddy. And then x2, y2. Okay, so now, y2, now it's like regular. Now make a line. So find your slope. y2 minus y1 over x2 minus x1. So that's going to be 47 tenths. You guys with me so far? Yes. Okay. 47 tenths. Now, again, it's exactly what we've been training for. Y minus y1 equals m times x minus x1. Y minus 8 equals 47 tenths x minus 94 tenths. No one wants to work with fractions, so I would suggest multiplying 10 to both sides. Distribute that 10. 10y minus 80 equals 47x minus 94. Add the 80 to both sides. 10y equals 47x minus 14. Divide by 10 to both sides. And I've got y equals 47 tenths x minus 14 tenths. They asked for us to find the weight of a panda after 7 months. So how do we do that? We're going to extrapolate. Plug in. For what? What does x represent in this case? No. What does x represent in this case, guys? Age. Don't they want to know the approximate weight for the 7-month-old? So, what do I plug into this x here? 7. In this case, again, this is the one time you're going to do it. You are allowed to use a calculator for this. I'm not going to make you go through all of this. You are allowed to use a calculator for this one final calculation. Make sure you do it correctly, though, guys, in the calculator. The way you would do it is 47 times 47 in your calculator. So in your calculator, you go 47 times 7, okay? Hit equal. That's going to be 329, okay? So that's going to be 329. Then just go divided by 10. So that's going to be 32.9 minus 1.4, right? 14 divided by 10 is 1.4. So this is going to equal 31.5 pounds. Now, let's see if this is reasonable. Let's go back to my graph. The 7 is about here, right, guys? Let's see where this hits it. Right here. Is that about 31.5, roughly? See how awesome that is? That's how you do this. So again, step 1, graph the points. If you can graph the points, guys, and oh, one big thing I screwed up. I'm glad I went over this. Gotta label your axis. This is age. Gotta label your axis. And this is weight. I apologize for not doing that before. That was my bad. That was my fault. So step 1, label the axes and graph the points. Anyone have a problem with that so far? I'm not trying to be rude. I just want to make sure. Okay. Step 2, find your anchor points, which in this case are these red X's. And then connect those red X's together. As long as that line is relatively accurate, I'm pretty fair. Like I said, this is not accurate. I'm sorry. That's not accurate. This is not accurate. If you just go like this and these 2 points, that is not accurate, okay? Relatively accurate, though. Once you find your trend line and you have your anchor points, you are allowed to round your anchor points to the nearest unit, and now you solve for the equation. You make an equation. How do you do that? You find the slope, y2 minus y1 over x2 minus x1. Then you plugged it into the point slope form. Y minus y1 equals n times x minus x1. And then you just did a bunch of math. And then at the end here, when I had to plug in, at this stage, you are allowed to use a calculator here. You are allowed to use a calculator here. Now, the way I'm going to do it on the test is like this. I'm going to give you a fourth if you can graph it. A fourth if you can find the anchor points and make a trend line. A fourth for writing the equation, and then 1/4 for actually solving it. Okay? Sir? Yes, that's what I just said. That's why I went through all of this. You have to show me the anchor points. Because if not, I don't know what you're doing. I don't know what you chose, sir. Show the anchor points with a little X, please, and thank you. Sir?
Wouldn't you reduce 14/10?
You can reduce 14/10 to 7/5. That's fine. But since I use a calculator, I got lazy. Yes, sir?
Probably more work, but can't you just multiply everything by 10?
Yes, you could multiply everything by 10 and then plug everything in and then divide by y, yes. But I'm going to let you, for this one calculation, use a calculator. If needed. Sometimes it'll be easy and you can do it. But that one's a little bit arduous, okay? Does that make sense, boys? Promise. All right. God bless you all. Thank you very much. And have a great day. That is it, my friends. That is it.